on? Yep, okay. Hi, I'm here to talk about hacking fibre channel networks, which is something a bit different, I think, from what most people are looking at. A little bit about me first. As was already mentioned, I did my engineering degree at ANU, where I specialised in electronics and telco communications. I worked for Telstra straight out of uni. I've worked for the EPS and government for several years, and at the moment I'm with Cisco. So my hobbies include the B-Sides Canberra organising, which is on straight after the ACSC, a bit of a plug. We also do monthly security meetups at ANU, and I've been to other conferences as well. So this talk just comes from building networks and noticing a lack of security. So it's more of doing it outside of work hours. Definitely my comments here are not Cisco's, they're my own. And I also love GIFs, so every time I sit down to write my talk, I'm on giphy.com looking at the GIFs instead, and so they're scattered all through the talk for some fun. So this is what I'm talking about today. I'm going to start off with a general introduction to storage networks and the fibre channel protocol. Then I'll go over how I built a fibre channel network at home for research, and then some of the security features and weaknesses of fibre channel, demonstrate some of the attacks I could do at home, and then the mitigations at the end. So I'm not sure how many people here have worked with fibre channel, but pretty much fibre channel is used for storage area networks, which is a term that will define all the hardware and software infrastructure that allows the computer to access storage that's not directly attached to it. So hard drives use the protocol SCSI, and most OSs will recognise that protocol. So what fibre channel does, it encapsulates the SCSI protocol to allow it to be transported across a network so that you can consolidate your storage into a storage array. I've got some facts there. Fibre channel is still pretty huge out in the enterprise. So why are we going to look at fibre channel security? Pretty much it's, from my experience, always out of scope for security assessment. So no one really seems to look at how you've set up your fibre channel network in the back end, although you'll look at your entire network in every other way. And the reason I get for that is that it's a closed network, you can't really attack it, it's behind the server. Hopefully today I'll convince you otherwise of that. Also in the enterprise environment, there is a growing desire to virtualize, so that's server virtualization, infrastructure as a service, and blade systems. Which means that you're seeing more of this fibre channel back end. You're seeing, server profiles that are moving around your enterprise, and this is enabled by what is known as WWN spoofing, which is an attack vector, which is now actually becoming a feature in the enterprise environment. So these are some blurbs from vendors. So I haven't said which vendors they are, but as you can see there, what they're saying is when you read through it is that the blade will boot from the fibre channel SAN as a feature. You can move your profile of your blade around your chassis, multiple chassis, and that's done by moving the WWN from one profile to another. And likewise, another vendor's doing exactly the same thing there. So so the point is, what seems like a secure network, where you've got your outside firewall, your inside firewall, your DMZ, you've done everything you think's right, you've passed accreditation, may not actually be as secure as what you first think when you look at the storage network in the back end. So a little bit more detail on the components. We've got the host bus adapters in the host service, which is pretty much just a network card for fibre channel. We've got the fibre channel switches, which create the fabric of the fibre channel network. We've got cables, of course, and then we've got the storage processors, or some people call them controllers, and similar to the host servers, they just have a HBA in them that's acting as a target rather than an initiator. And then, of course, we've got the disks at the back end, which are all rated and stuff. So how did I do this at home? I couldn't go into one of my customer networks and say, I want to see how I can attack your network. So I needed to replicate it at home. It was actually quite cheap, considering people say fibre channel is prohibitively expensive. You can see I could set up, I actually set up 3 nodes in my 5-channel network. So I got my micro servers. They're really quiet, don't use much power. Got a brocade switch, some SFPs, the LC cables, and then 2 of the QLogic HBAs. I bought the PCIe ones. They're a bit more expensive. You could probably do it cheaper if you've got full servers. So putting it all together now, so this is what my network at home is looking like. I've got I've got a DMZ server, which is my untrusted server. I've got my prod server, which is my inside server, and they just, even though at the front end they're probably one's in a DMZ and one's inside the network, in the back end they're sharing the same storage network. So further to that, each node in my network has a HBA in there, and each HBA is associated with a WWN. And this is probably like the first building step for fibre channel. So it looks similar to a MAC address, but they're WWNs and they're completely different. So a bit of a snapshot of fibre channel security. In terms of authentication, in most cases it doesn't exist. And there is, and I'll cover this in the mitigations later, there are options for authentication, but they're seldom used in networks these days. Authorization is done through WWN zoning and LUN masking. So it's there, but we'll see that's not very strong later. And encryption, fibre channel uses no encryption at all. So it was great getting out the fibre channel protocol analyzer. I could see everything that was happening. So the attacks I'm investigating today is the name server pollution attack, session hijacking, e-port negotiation, and then I'll finish off with WWN spoofing. So going a bit deeper, so fibre channel is similar to other networking protocols in that there are several layers at which it works. Similarly to the OC model, the layer 0 is the physical layer, and right up to layer 4, which is where the actual data being encapsulated sits. So we have, so what we're looking at today is the SCSI protocol, but you can see there it can encapsulate IP and other protocols as well. The most interesting layer for us to look at is FC2, because this is equivalent to the MAC layer in regular networks. It's the link layer, so it controls things like the session state, you know, fabric login, and these sort of things. So looking a bit deeper at the FC2 frame, the main components of the frame is the start of the frame header, the payload, the CRC, and then the end of the frame. And within this, the frame header again is probably the component that you want to look deeper at as well, because most of the data and the control of the fibre channel is in that. So along the top there is the FC2 frame, and it's enlarged the header fields. So you can see there we've got source and destination addresses. Now they're 24-bit addresses, they're not the WWNs that I was talking about later, so I'll talk more about how they come up with these source and destination addresses. There's the sequence ID and the sequence counter, which identifies the sessions, and then the type field, which is the lets them know what the upper layer protocol being transported is. So this is my protocol analyzer. So looking at my network at home that I set up. So this is me bringing my server online at home, and so you can see that the HBA is logging into the fabric there. It does a fabric login, a port login. The DNS is similar to spanning tree, but a fibre channel protocol version. What's interesting is the source and destination numbers there look a bit odd. They're not IPs, obviously. That's the port IDs that's being sent back and forth. So I've drilled down into this a bit more so you can see what's happening. So my server is attached to the switch. It comes online. First thing it does is it sends a frame to the well-known destination ID of FFFFFE, which is similar to like a broadcast address. And it sends it from source 0000, which lets the switch know that it doesn't have a port ID, it needs a port ID. So the switch will reply back here with a destination ID of a port ID is allocating that HBA from the FFFFFE. Then the server will then go back to another well-known broadcast port ID, which is FFFFFC, with its source ID of the port it just received. So it's letting the switch know, so the FFFFFC port ID is the name server on the fibre channel switch. So what it's doing is it's letting the name server know, hey, I'm here, this is my WWN, and this is my port ID, which then populates the name server table. So there's absolutely no control on on who's sending that frame. As long as you know that it's got to go to FFFFC, you can send out whatever you want into that server. So I think everyone here in security probably already knows, well, that's not great. Yeah, so pretty much that would be our name server pollution. So I've got a picture of a name server down there at home. But yeah, pretty much if you wanted to poison it with false port IDs or a port ID of someone that you wanted to man in the middle, you'd be doing well. So that's the first attack. Second is session hijacking. So to have a look at this one, I mean, it's similar to the TCP session hijacking exploit, where there's a known session happening. Originally with TCP, it was weak sequence numbers that allowed people to take over sessions. It's probably even more trivial in fibre channel, which is exciting. So the fibre channel sessions are controlled by the sequence counter and the sequence ID, which I mentioned earlier. So I grabbed out my protocol analyzer, watched that again at home. So what you've got on the right here is the header of a frame that I've sent when I'm copying data to my SAN. So as I click through it, I've highlighted the sequence ID. You can see that the randomization there is not great. I can pretty much guess what's coming next. So that was a pretty trivial attack to do too. The third one is the e-port negotiation. So I've gone through an n-port login, which is a n-port, but when a switch connects to another fibre channel switch, it does e-port negotiation, which is like, I always think of it as extension port because you're extending your SAN, but it forms what they call an ISL link, or similar to on a Ethernet network, a trunk. So once you negotiate that, you get a full vSAN and zone transfer. So it's an effective way to enumerate your fibre channel network. And by default, all ports are set to negotiate to ePort. So moving on to the last attack, which is the authorization attack. So the authorization for a server on a fibre channel network is usually done via WWN zoning or LUN masking. This is done usually using the WWN associated to the HBA. So, so by grouping together your WWNs on the switch, you're making sure that servers not inside that group can't see the storage. And LUN masking is very similar, but it's just done either on the client side or on the server side. So just going over zoning a bit more. So this is my home network again with the WWNs, and I've set up the zones there on the switch, and pretty much all I'm doing is grouping my WWNs into appropriate zones. And you can see there that the asterisk indicates that all those servers have been logged in to the fabric. So we have the prod server zone, and we have a DMZ zone. This is the storage controller I'm running. So I was really lucky. Linux have released support for target in their most recent kernel. So I'm running Fedora 23. This is target CLI, and it allows me to export my logical volumes on my Linux box as targets. So pretty much what I've set up here is I have a logical volume. It's been mapped to a block storage or storage 0. Down here you can see block storage 0 has been mapped to LUN 0, and then mapped LUN 0 is now being mapped to an ACL. It's actually being exposed to the WWN that ends with CBF4, which is my prod server. And likewise, storage 1, LUN 1 to the other server. So that's the LUN masking and how it works. So I wanted to do live demos, but it was a bit hard to bring in all the fibre channel stuff, so I've recorded some demos. This first demo is SAN enumeration. So before you can attack, you want to get to the storage of another server, you need to know it's there, right? So I think I read somewhere 80% of all attacks begin with enumeration. So this is just going over the network again, showing you the zone sets on the switch and the LUN masking, set up how I explained earlier. I'm getting on my DMZ server, so I'm assuming that the DMZ server is an untrusted server, probably more likely to be attacked by an attacker. The attacker's got non-gotten admin privilege, but they can't seem to get to the rest of the network, so they're going to have a look at the back-end storage and see how the storage administrators set it up. So you can see there that you can see we've got a fiber channel disk there up the top. It's been presented as, I think it was E drive. So just opening the SANsurf application, which is a vendor application that allows you to check out your fiber channel network. So we connect to the local server. It then enumerates the network that we've just been on. So the GUI's a bit clunky on it. So you can see the storage there, which is LIO, that's the Linux target kernel module. And then we've got the switch. You can see what ports it's logged in. That's the server I'm on. And there, I see there's another HBA on the network. So this is the HBA that we think, well, let's see what's on that server. So moving straight on, we know there's another server on our fiber channel network. We want to see if we can get anything from that. So back on the same server, we're having a look at what's on our fiber channel disk. We see we've got boring DMZ untrusted files there. We double check that E drive under storage, and it's a fiber channel drive, so we know that we've got a link into the fiber channel network there. Using another vendor tool, One Command Manager. And this is really great because this is a feature of the tool. So opening up the HBA into maintenance, and down here there's a button that says change WWN. So we open it. Yes, we want to continue. We put in the HBN that we discovered earlier. So we want to see what that server's getting to see on the network. It does say you have to reboot, so it is not a hidden attack, I guess. It's going to be quite obvious. But hopefully once you've done it and the network administrators realize the DMZ server's gone down, you've already pulled all your information off. So logging back in, it's rebooted. I actually open OC Manager just to verify that the WWN was changed. It's a pretty slow server. I did run it off a USB stick, so I didn't bother any of my other stuff. Yep, so verifying the WWN, I can see there on the HBA it's got a new WWN. So checking the disks, and I see I'm pretty happy here. I've got another fiber channel disk I've mounted through my new WWN. Opening my browser, I see a new drive, and there I go. I've got confidential internal secrets and my production Git repo all there. So I pull that before people realize I rebooted the server, and that's it. That's the attack. So we do our happy dance. So yeah, so that's the end of the attacks. I've got a few mitigations that would be worth putting on if you were going to set up a fiber channel network. So it is possible to do zoning on ports rather than WWNs, and you can hard bind your port to a WWN. This can't always work if you're in a blade system, and a feature of your blade system is that you want your server profiles to move around. But if possible, do something like that. You can lock your ports to specific types, so E ports and F ports. This is similar to setting up access ports on an Ethernet switch. You know, you don't want everything to be able to negotiate a trunk. Likewise, you don't want your fibre channel network to be negotiating E ports. Use one of the new authentication protocols. They're similar to me, they remind me of .1x, like, so it's a little bit of overhead setting that sort of thing up, but definitely worthwhile. And in terms of your design, don't share your SAN resources with devices at a lower security level. So if you have a DMZ, don't put it on your storage array. And so my conclusion is fibre channel is a weak protocol, and it's been weak for a long time. And by default, it's even weaker, so if you could get in there and secure it, that would be great. And probably my key takeaway would be that those people doing security assessments, make sure you have a look at the fibre channel network as well as the rest of the network. And yes, it's a balancing act. So, poor old guys. Let's see. So that's it. Any questions?